Okay, assuming that you've gotten into Blackboard and we're looking at Lab 10, you should fill this stuff in. Make sure you've got Turbo C++ Express up as well. And we're looking at loops here. Now, just before we get started, if we take a look back here, you'll find also that there's some notes for Lab 10 under course documents. So if we go back there, we should be able to read through those and get an idea of what's going on. So let's take a look when this thing finally redraws. It's slow. But when we go into the notes, oh, here we are, sorry, my mistake. So let's look at course documents. And when we do that, there's some notes right near the bottom, I think, for Lab 10. So let's read through those. Notes for Lab 10. There we go. So we click on this, and let's see what we've got. And it talks about while loops, for loops, do while loops. So you can read through this, but it's not printable. So again, you're going to have to make notes on this. But it does go through the various types of loops, for loops, while loops, do while loops. And this is one very similar to what we're going to be working on today for the first part. And what it talks about is flowcharts. When we talk flowcharts in any of these notes, if they haven't been updated yet, we're really talking Nasty, Schneiderman, or what I call structured diagrams, which there are notes for online. So product equals and so on. And this is one of the kind of questions that we're going to be doing today in the lab. Strange enough, this is using nested loops, and we're going to be using this again and seeing this again actually in quizzes and final exam sorts of things. So this is a very important concept. And next semester in PRG 255, you're going to be using the same kind of inner-outer loops to initialize two-dimensional arrays and so forth. Okay, so make sure you've read through all this at some point. And it goes through flowcharts again. These again will mean this. So please read through that at some point. So this is some information that you're going to need to know. Also, when you take a look at some of the other stuff on here under Blackboard, let's see what else we have here. Logical expressions 2, number critical logical expressions, blah, 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 blah. Structured diagrams. So when you get into structured diagrams, this is some important things because you're going to be needing to do, and we're getting near the end of the course now where you're going to be doing a project which requires structured diagrams. Strangely enough, if we look up here, we can find that this is indeed printable, and you should print it out. So what you're going to find is the brackets on main here and here. This is each corner of the box, so like you have to think inside the box for structured diagrams. If we take a look at this one, we can say A gets the value 5, and that's replaced with an arrow. So 5 goes into A, 7 goes into variable B, and so on. And A plus B goes into C. And then all this printf stuff says the screen gets variables A, B, and C, and it doesn't really care about the kind of formatting. So once you've gone through this, you should print this out. And the thing that we're going to be looking at today, now there's a little bit of stuff on selection, and it should be a quick review in here in terms of math symbols and so forth. And one of the things that we talked about before is there's a big difference here between A equals 4, which is putting 4 into variable A and assigning it that, and A equals 4, which says is what's in A equal to the value 4. The first one is an assignment statement. The second one is a logical expression which evaluates to 1 if it's true or 0 if it's not. So there's a lot of things in here that we need to know as we're finishing off this stuff. Now, if we take a look here, and this is a very important thing that you need to know. If we look here, this is an if statement here, and that's this box here. Right after it, there's another if statement, which is a box after it. Now, when you take a look at the way this works, depending on, now you can read through this, there's only one path through because we got particular conditions set up, A less than B, A equals 7. But if you think about it, depending on how you've set things up, it can either do this and this, or neither this nor this, or it can do this but not this, or not this plus this. So there's 4 possible outcomes, really, of an if followed by an if. 4 possible outcomes. Now, if we slide down here, this is a little different than an if-else, because if-else that we've been dealing with is really saying all of this is one statement. And since it's all one statement, it's either going to be this outcome, or this outcome. There are no other possible outcomes, one possible outcome. So those are some of the things that we should have learned so far. Some other things that we're going to look at today is this is a while loop, and we say A equals 4, so there's a variable that's being initialized above the loop while a less than or equal to 7 here. Notice these are brackets here, so that's the edges of this box. So we're going to get used to drawing structure diagrams like this. Screen gets a equals a plus 1, so it's fairly straightforward. And if you set it up in such a way as the increment or decrement is at the bottom of the while loop, then what you can do is rewrite that completely into a for loop, and we'll be taking a look at that as some of the exercises that we're going to be doing. Now, in the previous lab, we actually set up a do while loop. And a do while loop, there's the brackets there, and you can see there's the edges of our box here, and underneath is our while statement that says what's going on. And to finish this off, if we're doing something that's going to involve code being somewhere else, such as a function call, something like this, and we put double lines and a return bob, but even if we're saying that we can't fit this code into the structure diagram, we can just put a letter here and then say structure diagram for A is an exploded view. More about this later. But let's get back into Lab 10. Now, if you've read over this information, it says write a program to calculate the sum of numbers. The user enters a starting number, a largest or ending value, and a step size of the numbers to be added. And if he does this for 5 or her, for 5, 12, and 2, then it's going to add 5 plus 7 plus 9 plus 11. If it adds 2, it's too big because it's bigger than 12, and it's going to generate the sum as shown in the table below. Now, when you look at things, there's things that have to be done before the loop, things that get done in the loop, and things that get done after the loop. So there's a lot of things that have to happen up here. We have to initialize all the stuff that we're going to do first. We're going to have to, in this case, since we're using a sum, we're going to have to set that sum to 0 above the loop, because otherwise when we start adding numbers to the sum, it's going to add whatever the default crap, as we saw before, was in sum. So each time we're going to say sum equals sum plus the loop parameter, sum equals sum plus that. So in the first case, if sum is 0, sum equals sum plus 5, that's 5. Sum equals sum plus 7, 7 plus 5 is 12. Sum equal, which is now 12, is sum. Sum equals sum plus the value again, so that'll be 12 plus 9 is 21. 21 plus 11 is 32, and that's the way it's going to calculate the sum of the numbers from 5 through 11. So this is the kind of thing. So we're going to have to set sum equal to 0 before the loop. We're going to have to print this out before the loop, and then afterwards inside the loop we're going to then print these values. And notice we've got probably tabs or something in here, and then this final statement here is going to be done after the loop. So as long as we have that in mind, and as it says draw the flow chart, it'll be a structure diagram here for this. That's the kind of thing that we're going to have to do. So let's go and start our whole last lab, thank goodness. So let's go back and bring up our Turbo C++ environment, and we're going to say new as always, program. We're going to set up Win32. This is again Lab 2. Sorry, I meant to say Lab 10, LAB 10. And we'll say OK. And again, we're going to have to go through this business of setting stuff up as our wizard thing here. It's a little bit slow. Of course, we're not that fast today either. So application settings, we're going to send up empty projects, they finish, and here we go. So once we've got that set up, we're going to have to again go to source. As we've always done, right mouse click, add new item, and we're going to again C++ file, and this is going to be lab 10A. So once we've got that happening, let's go full screen, and we're going to put in our stuff as we've always done, our programmer's block. So title, program to generate a sum of numbers in a table. And as always, we're the author. So make sure you get all this stuff filled in. Now, if you've got a program from before that you can actually grab all this stuff as a standard template, then that would be good. And today's date is, let's see, June 12th, 2009, and description. Now we'll write this up not as the details that we did for functions, because this is pretty straightforward and we're not using functions for this. So we're going to write it in a way that we can use it as an explain to user. So let's see, this program will ask you for a start value and end value and an increment value. It will then sum the numbers, well, sum these numbers, and print the final sum. That's basically what this code is going to do. And as I said, we've written it in such a way as we can use the description here as an explain to user, so we'll do that, and we'll just write it as all one big main line. So we'll make it simple on ourselves because we had a little trouble with functions, but that's okay. So include section, or standard include, is number sign include, and you should be very good at doing this by now. Standard o.h and bracket defines for printf get, let's do scanf, get char, get string, put string, and f flush, and number sign include conio.h defines for the getch command if we're going to use that, and number sign include standard lib.h. Now we're not doing any fancy math functions of sine, cos, tan, anything like that, so we don't need a math function. So if you include that, I'm going to take off marks. So integer main void, and we'll put our brackets and our closing bracket, and don't forget what we should do down here is put in a return 0. Let's always try to remember return 0. Some compilers are very fussy about that though, that particular circumstance. This one, not so much. So again, the very first thing is going to be variable declarations, and explain to users, because we're going to do that, and then get user input, and then after that it's just going to generate output. We're going to do calculations inside the loop, so the output is going to be generated on an ongoing thing inside the loop. So those are the sorts of things that we're going to do. Now let's take a look. What do we need? Well, obviously we better take a look and see what kind of data that we're using here. So let's take a look, and if you look here, these are definitely not floats, they're not chars, so they're going to be integers, and we've got a starting integer that we're going to put in. Let's take a look here. We got a starting integer, an ending integer, and we have an increment size. So it's going to go from 5 to 12 in steps of 2, 5 to 12 in steps of 2, and as we said, 5 plus 2 is 7, plus 2 is 9, plus 11, plus 2 is 11, plus 2 is too big, so it's going to stop when it hits 11, and it's going to sum up 5 plus 7 plus 9 plus 11 and get these numbers. So 0 plus 5 is 5, 5 plus 7 is 12, and so on, as we talked about before. And once the loop is finished, it's going to then print up the sum of the numbers is and give a final thing of what this sum is here, which is our 32 here is just going to be rewritten there after the loop. So let's see if we can put all that together. So variable declarations, what are we going to need? Well, we're going to need a bunch of integers. Let's call it start for our starting value, which is going to come in from the keyboard, end for our ending value, increment for our increment variable. Now we also need a couple of other things. We need a sum, and we also need a loop parameter, and let's call it x. You can call it anything you like, but I'm just going to set it up this way. So those are things we need to, we're going to get this from the keyboard, keyboard. This is going to be our sum that's going to calculate the sum, and this is going to be what's going to keep track of the numbers as they go through our loop. Explain to user, well, we've seen that so many times before, so we're just going to put system clear screen, and once we've got that, we're going to do some put strings. So when we do that, let's see how many need 4, 3 plus a blank line. So let's just grab this, Control C, 1, 2, 3, 4, grab this stuff here, and once that's done, we've got our explain to user done. And as I said, we're not going to, we could functionalize this, and that would be a good thing if you could and figure out a way to do that, but for now we're just going to do the simple thing because we don't want to mix too many things in all at once and confuse the heck out of you and me. So let's put all this in. So we've got explain to user, And get user input, what we're going to do is we're going to ask for 3 integers. So we're going to do printf. We'll just raise this up a little bit. Printf, and we've got a blank line here, so we can do printf right away. Input the start value, and we're going to flush. Always we're going to do this as a standard procedure. Flush standard in, and put the comment in here, flush keyboard buffer. Now right at the start it doesn't make a lot of sense, but if you ever set up a loop, the next time you come back to this first statement you'll want to flush as well if we set up loops as we saw before. Scanf %i or d. I or d is good. And we'll put ampersand. Don't forget the ampersand. That can cause your system to crash. And we'll just grab Control-C to start and plunk it in here. So once we've got that happening, we've got please input your starting value, and if you think about it, we've got two other values to come in, so we'll just Control-C, Control-V, 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 input your increment value, or no, end value, isn't it? He's getting ahead of myself again. End value. So in this case, we just double click there, Control-C. Don't you like copying and pasting? Look how fast we're putting this together. And input your increment value. And again, let's go up here, and because we're lazy, Control-C, let's do that, increment. So we've got our get user input. Now we've also got some things that we're going to have to do before the loop. So let's put a thing in and call loop initialization. Now you don't really need to do this, but the first time through it might make sense. In other words, things that have to be done before the loop. So some of the things we talked about is we have to set sum equals 0, and the comment here would be initialize sum to 0, because otherwise sum is going to have crap in it. And the other thing is that we're going to have to do, and if we take a look back here, we're going to have to put up a title, value and sum. And notice value is not in the left margin per se, but it could be in the left margin, but we're going to tab it over. So let's do that. So we're going to tab and a couple tabs over to maybe get sum if you look at it here. So let's do that. So we're going to put in our title, printf, backslash n, a couple of blank lines, and one backslash tab. And let's see, what was that again? Value and sum. So put in value, and backslash tab, and put in sum, quote, bracket, semicolon. So that's going to be, oh, and we might want to put in a couple more blank lines here to move it down so we've got our table. If we take a look again, you can see that the table, then a blank line, so it's going to start down there. So these are things, loop initialization, before we get in the loop. Now we can also break it down into saying, okay, these are things inside the loop, and the output's going to be the final statement after the loop, inside the loop. Now what we're going to use for this, we could use a while loop, but we're going to use a for loop, and we're going to say for, and our variable here is x, because we used x here as it's going to be our loop parameter. So for x is going to, let's take a look, we've got 3 values. For x equals start, oops, that should be a semicolon. Let me just zoom in here. So for x equals start, semicolon, and all the things in here are semicolons to separate the starting. X less than or equal to end value, semicolon again, and x equals x plus increment. Now if you've looked through your notes, and you should, there is a way of making this a little bit smaller, especially if you use supercalifragilisticexpialidocious-Schwarzenegger instead of x, and then you want to say equals supercalifragilisticexpialidocious-Schwarzenegger plus increment. There's a short form of this. X equals x plus increment can be rewritten as x plus equals increment. Now again, what's the thing to do? Never type in what you think it is. Control-C, double click here, and Control-V to get it right every time. So once we've got that in, what we're going to do is put in our bracket. And what do we do inside our loop? Well, let's take a look and identify what's inside the loop. This is the stuff that's inside the loop. So we're just going to print out what x is and what the sum is. Now, so let's try that. Printf, and we're going to have to go down. We've already gone down 2 lines. So after we've done this, excuse me, so we can either go down 2 lines and at the end of the printf put in a backslash n because we've used two backslash n's here. So we can say printf quote, and what are we printing out? We're printing out x, and we're actually printing out %i, and probably want to put in a backslash tab first, right? Backslash tab, %i, because we want to line it up with value, backslash I, or backslash t, %i, quote, comma, x, comma, sum. Now this might seem okay, but then when we think about it, what is sum going to print out as the first time? Sum is going to print out as what the value is for sum, which is 0. Now I don't think it says x equals start. If we type in 5 as it says, this will print out as 5. I don't think we want to have 0. If we look back, we don't want to have 0 printing out here, we want to have 5. So we have to, before we do this print, and this is the order of operations thing again, is sum plus equals sum, which is the same thing as saying sum equals sum plus, sum equals plus equals x. I do apologize. Which is really the same as sum equals sum plus x. So this is the same thing. So what we're going to do is sum is going to take on, if this is 5 the first time, this is 0 plus 5, 0 plus 5, that's going to be sum, which is going to be fine. So everything should work to this point. Let's see what else we have to do. Now, if we don't do anything after this, we're going to be in what's called an infinite loop, because what we have to do is add the increment, and we're going to add the increment to x. So x plus equals increment, which is the same thing as saying, let's put a comment, x equals x plus increment. Because without incrementing, it's going to stay in the loop, because x is always going to be the start value and it's never going to go towards the end value. So to finish this x or for statement off, we're just going to put a bracket in here, and that should do what's in the loop. Now, to finish this off, and let's take a look, you can see there's a couple lines in there. And what did we forget to do up here, people? To move this down, otherwise it's going to go on the same line, is go down a line. Go down a line. Now if we had to put it here, we would have taken out one of these backslash n's up here. When we're printing this out, we could have put one backslash n and put a backslash n at the start, but we'll put it here. So we only really need one backslash n here, printf backslash n, and we're lazy, so let's grab what it is. The sum of the numbers is, Control C, let's go back, Control V, sum of the numbers is %i, quote, comma, sum. And that should pretty much do it. And this is all really under the output, and we put this in the wrong place. Let's Control X, and this is our final output. And what we need after our output is obviously the get ch. Now assuming we've done all this right, let's just tighten this up a little bit and take out some blank lines. This should work. I'm not saying it's going to, but let's run it up and see. So it's compiling, warning, linking, yay, it's going to link, it's going to run, yay. And let's see what's going to go. So let's see, embedding, manifest, boom, 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 boom. Here we go. So it says putting in our started value. So let's take a look and go back to what it was that it asked in the first place. Let's bring up our output. Come on, why is it do? Okay, let's click, sorry. Let's bring up our output here. Alright, so what we want to do is put in a starting value, and it talks about that up here, 5, end value 12, 12, and increment value of 2. Oops, something's wrong. It did 5 and 9 and didn't go, and it says the sum is 14. So we do have some issues. Let's see if we can figure out, because my 9-year-old says figure out. So let's see if we can figure out what's going wrong. And let's look at our code. So it's not doing exactly what we want. So let's take a look and see what we did wrong. So x equals x plus increment, x equals x plus increment. Do we really need this statement in here? No, we don't. So some people will get confused with for loops and while loops. and just realize that it's checking for the end value right at this bracket. It says x equals start, and if start is less or is not less than or equal to n, it won't even go in this loop. But here, this increment is actually automatically done here. So let's do this again. Let's punch it up, because some people will get confused between while loops where you have to put the increment or decrement near the bottom and for loops where it's already there. So let's go back and let's bring up our output again. Let's bring this up so we can see what's going on in our output window. So let's take a look. So we're punching in 5 and 12 and 2. We can't do that because it's flushing, otherwise it would have worked. We'll put in 12 and put in 2, and we'll see that, yeah, it's looking pretty good, isn't it? It's doing pretty much everything that we want except for one minor thing. And you'll see here, let's just slide this over a little bit to the right. Notice that value, under the L, we've got these numbers. Here it's under the V. The U, it's got these numbers, so a slight change in format. So we can do that. Now if you think about it, we want to move this over how many places? 2 places, and move this over 1. So let's see how we can go about doing that. Let's switch back to our program so we can make it perfect, or as perfect as we can get it. Notice here it's saying x is printed %i. To move it over 2, we would say %3i, because that would put 2 spaces in the front. In this case, we want to move it over 1, so we'll make this %2i, and let's run this up and see that indeed when we do this, we'll have everything coming up exactly, or pretty darn close to being exactly the way we want. So let's see. Let's do 5, 5, 12, 2, and indeed, that's what it does. It lines things up a little bit better in terms of how things should be. And so when we take a look here, the L, so that's about as close as we're going to get. So what I want you to do once you've done this, as we've always done, is grab the output, save it in a file, save it in the same file, and then we'll continue on. Now the structure diagrams, you're going to have to talk to your instructor or read over the stuff. Either way, you're going to have to come up with a structure diagram for this based on the notes on structure diagrams. So once we finish this, we're going to say full screen. We're going to go back here. We're going to notice there's no stars. If there is a star here, you're going to have to say File and save Lab 10A. And then we're going to say go down here and X or remove this. There we go. And right mouse click, Add New Item. And again, this time we're going to call this Lab 10B. Okay, and it's going to remember that it's this kind of template, and we did something stupid, didn't we? Yes, we should have put that in, but let's see what we're up against here today, because there may be something that's not exactly what we want. Now this one is so simple to do that we don't really require a lot of stuff other than a programmer's block and include section and a simple inner outer for loop. But the hard part is to analyze this, and as we saw earlier, there's some notes in the course documents that show you how to do this, and we'll sort of generate this very quickly. Let's see what else we're up against here, and then we're going to modify Lab 9A. Now it says to modify it so that it's going to actually be a loop. And the bottom line is that we've already done that. So all we have to do really for Lab 10 Part 3 is to draw the structure diagram here for that modification. And again, you can look over the notes. So we've only got really one program to do. Okay, so we've already done that part. So let's go back here and see how to do this. And it shouldn't take too long. Now, if you think about it, there is a way to do this. Now, first thing, we're going to use inner outer for loops. We're going to say for, and the outer loop is going to go from 15 to 45 in steps of 10. Then the inner loop is going to take whatever the x value is. Let's say we're using x and y as our loop parameters, and say y. Y is equal to x, and this is 5 bigger than x in steps of 1. So, and it goes through this in the notes, so I'm not going to spend a lot of time going over stuff that you can read. So let's see how we would generate that. So let's do something and save ourselves a little bit of time. Right mouse click, let's just remove this. And right mouse click again, add existing item. Let's bring back Lab 10A and go here. And let's grab this, because we're lazy, Control C. Let's remove this again. And let's, since we've already created it, Let's add existing item. Let's bring up lab 10b. And when we go here, we can actually just go full screen, Shift Alt Enter, and Control V that in, and we've got something. So this is programmed to generate table of values, table of numbers using inner slash outer for loops. Now this is one similar to what's going to be on the exam. Now to make this a little bit simpler, what we're going to do is we're going to Control C and put this in exactly as the description. We're not going to really care a lot about, things like explain to user. We're just going to do it. So this is going to be fairly straightforward. So let's put in integer main bracket void, and again the brackets opening and closing, and the return 0. So we always remember to put that in. And up here, here's what we're going to do. We've got, as always, our variable declarations. And what we're going to need is an inner and outer for loop. So we only really need two. And it's not float, it's going to be integer. Let's call it x and y. And what we're going to do is, we're not going to worry too much more than just say for. And let's take a look at what our numbers are. Let's go back. And the outer loop is going to be, click, okay. The outer loop is going to be from x is 15 to 45, and I think you can see that this is in steps to go from each of these. This is what the outer loop is going to generate in steps of 10. 15 to 45 in steps of 10. So for x equals 15, x less than or equal to, less than or equal to 45, semicolon, x plus equals 10. Now that's our outer loop, so we'll put brackets, leave a little bit of room. There's our closing brackets, so that's going to generate the outer values. Now inside here, we're going to generate 4, and let's use y equals, and we're going to start off with whatever x was the first time. So y equals x, and so this case when x is 15, y is going to be 15, and progress on from there. When it drops out into the outer loop, x is going to be 25, so y will be 25 and base on to there. But notice that the starting value is going to be y equals x. The ending value is going to be y is less than or equal to x plus 10 in this case, or sorry, 5. So 15 plus 5 is 20, 25 plus 5 is 30, 35. So we can say that y is less than or equal to x plus 5. So let's put that in. Y is less than or equal to x plus 5. And the step size, which is the last part, is it's going up in steps of 1. So y plus equals 1. And that becomes our outer loop. Whoops. So we'll put in our, keep putting the wrong bracket here. Left bracket, and down here our right bracket. Now, what we want to do is this is where we want to print. So we're not printing x, we're going to print y because y is taking on x values. Now we want to keep it on the same line. If you notice here, this is all on the same line, so there's no backslash n's in this. But we're going to be using backslash tabs to tab it over, %i, quote, comma, and then we're going to print y. Now what that's going to do, if we look back, it's going to print all of this stuff over, but as soon as it hits the end, it's going to be out of the inner loop. In other words, when it's printed all the values from 15 up to, in this case, 20 in steps of 1, it's going to drop out and come down outside this loop here, and again be in the outer loop. So what our outer loop is going to do is it's just going to move down a line. Actually, if we say put string quote quote, it's going to move down one line, but I think you can see when we look back here, there's an extra line in there, so we're going to just do a put string backslash n. Well, let's run that up and just see what happens, and see if this is going to give us what it is we need. Wow, compiling and linking right away. That's a good sign. Embedding, bang. Now what did we forget to do, people? You got it. We forgot to put a getch after our outer loop. So let's put a getch so we can hold things open. And let's punch it up one more time. Okay, C declaration of getch, blah, 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 conformant. Who cares? Okay, we're not that fussy. Now, let's take a look. Wow, that's not looking bad. Let's take a look over here again. let's go from here right to our thing, and let's bring our output window up here and compare. And I think you can see that these compare quite favorably. 15, 16, 17, 18, 19, 20, and bang, 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 exactly what we should have. Now let's go back and see how this is working again. Let's bring this up full screen. Let's slide this down a little bit here. And let's bring up our output again here and see if this makes some sort of sense. So what it's saying here is x is going to be 15. Now you can actually set a breakpoint here and trace through and see all these things happening step by step, and that's probably a good exercise for you to do. It starts with x being 15, then it drops into this loop. Y equals x, y is 15. While y is less than or equal to 20, which is 15 plus 5, it's going to print what the value of y is, which is 15, then add 1, and 1, until it's not any longer less than, in this case, or equal to 20. Then it drops out of here, goes down a line, goes down another line, and then what it does is comes back here and increments x from 15 to 10 and so on, and just continues on. So again, as what we've done before, is make sure you've taken this output, pasted it in here so you can see it, and just realize that test questions in the future and on the final exam, this is one of my favorite exam questions. Now, it's not always going to go in an upward manner here in this chart. It could go downwards. It could go 45 to 15. It doesn't necessarily go up in ones. It could go down in twos or fives or something like this. But when you read over the stuff on the notes, hopefully this will make some sort of sense and you can figure out the pattern and come up with just about any solution for any possible thing I can throw at you. So what to do is just copy this in, and the last thing in the lab is you're going to draw a structure diagram for that. Your instructor in the lab can help you out with that, or your teacher in the theory class, because it's due the week after. And here all we have to do, modify the program from the previous week. Should work as described if the user selects A, B, or X, wrong message. And we've done this, I believe. Remember we did this? And we put up a loop. So I want the one with the loop version as a structure diagram here. That's all you have to do for this. And Lab 10 is now complete. Yay!